So section 2 is on a review of pre-calc concepts, and we're going to break this into 2 days worth. So we're going to do part 1 first, which is going to be asymptotes, domain, and solving trig equations. All right, so if we were finding the horizontal and vertical asymptotes of a function, if you remember, the vertical asymptotes come from setting the denominator equal to 0. Do you all remember that? All right, so what we're going to do is we're going to set the denominator equal to 0. Okay, so when I do that, I'm going to have 4x squared minus 2x plus 1 equals 0. All right, try to factor it. Does it work? It does not factor. Do you guys see that? Isn't that mean of me? 2 days in a row I've made one that doesn't factor. What do we do when it doesn't factor? Quadratic formula. So there could be rational vertical asymptotes. Like you could have 1 plus the square root of 2 or something like that, right? So when we do x equals negative b plus or minus the square root of b squared minus 4ac, oops, I did ca, but that's fine. You guys get it?
It's the same thing.
Yeah. All over 2a, we get 2 plus or minus the square root of negative 12 all over 8. What did I tell you about imaginary numbers in calculus? We don't have them. So what does this mean about our vertical asymptote? There is none. So we're going to say no vertical asymptote. All right, now horizontal asymptotes, I always told you that there was a shortcut. Ha, there's a shortcut. It's not really the first number, but it's the number with the largest degree, the largest exponent. Okay, so we're going to look for the largest exponent. So on the top, we have an x squared. On the bottom, we have an x squared. So we just look at our 2x squared over 4x squared. So we have 2 over 4, which is 1/2. So our horizontal asymptote is 1/2. Okay? All right, so the next one, this one does factor. So our vertical asymptote, if we try to factor, we're going to have x minus 2 times x minus 1. So it has 2 vertical asymptotes. So we have at x equals 2 and x equals 1. The horizontal asymptote, we look for our largest power. So what's our largest exponent? X squared. So we have a 1x squared on the bottom, but we don't have any x squareds on the top, so we put a 0x squared. We want it to be the same. So 0 divided by 1 goes to 0, so our horizontal asymptote is 0. All right, so the next one, C. So our vertical asymptote, yes, I realize that it's under a square root. It doesn't actually matter. We're still finding where the denominator is equal to 0. So when we square both sides, the square root goes away. And we can then factor x plus 2 times x minus 1, or x minus 2. So we get x equals negative 2 and x equals 2 as our vertical asymptotes. Now our horizontal asymptote is tricky. We did not actually, I don't think we did this in pre-calc. Okay, it's kind of a weird one. So I want to talk about what the shape of this graph looks, and then we'll talk about why this one actually has 2 horizontal asymptotes. Did you know you could have more than 1 horizontal asymptote? Isn't that weird?
It's just...
So you could have things that look like this, where they get closer and closer to a certain value, but they don't cross. Closer to closer on that side as well. So we're going to have to consider what happens as we plug in really, really big x values, really positive big numbers, and negative big numbers as well. All right, so let's look at this graph. So I went ahead and you guys can pull out your calculator too. So I went ahead and plugged it in for y1. So I did 1 minus x in parentheses, so all of that in parentheses, and then I divided by the square root of x squared minus 4. And when I looked at the graph, it looked a little bit funny. It kind of looks like there's 2 horizontal asymptotes, but it's kind of hard to tell because the vertical asymptotes kind of get cut off here. You guys might have a graph where it shows the vertical asymptotes drawn in, so it looks really weird. Have you guys seen those?
It looks like I can't really see your screen.
Yeah, that's what mine looks like.
Okay. So
So you might have something that looks something like where it's drawing in the vertical asymptotes. That's totally fine if you have that. All right, so it looks like maybe there's 2, but we're not sure. Okay, so what I said said is we're going to plug in really, really big numbers, positive numbers, and really, really big negative numbers, okay? So what I'm going to do, I'm going to go to a second table, and you should have it set that you can plug in anything. I'm going to clear these out because I already... Oh, of course, it's not letting me clear. What am I doing wrong here? Delete. Oh, delete, delete, delete. All right, so yes, if it does not let you plug in anything, you're going to do second table set, and you're going to make it so that the independent is highlighted with ask. Most of you guys, if you used the same calculator last year, it's probably already done. All right, so let's think about it. If I plug in something big, like 100, it's giving me a y value of almost -1. So then I go a little bit bigger. I'm like, oh, what about 1,000? Gets even closer to -1. Do you guys see that? Or 10,000, right? And that's where I usually go and I just hit a bunch of zeros and I'm like, well, what happens when I plug in a really huge number? And then my calculator actually told me -1. Now it's not actually -1. If you plug in like, I don't know what I just had, 10 trillion or whatever. If you plug that in, it's not actually giving you -1, but it's gonna get closer and closer to that -1. Does that make sense? All right, so what if I plug in a big negative number? So let's start with -100. Positive 1 point something, right? So it's different. It's now giving me +1. Do you guys see how it's working? So you can do -1, 0, 0, 0, 0, and your calculator can't handle it, and it's going to give me +1. Okay? So why is that? Let's think about it. Do you guys remember, you hated this section in Algebra 2. It's been a while. There was a section in Algebra 2 where you had things like x squared, y to the 6th, z to the 8th. And the answer, I told you to go with your gut, x, y cubed, z to the 4th. That was not the exact answer. The answer actually involved absolute value around that and absolute value around the y cubed. So I had you just put the absolute value around both of them, but does that make sense? Do you guys remember why we had to do that? You just remember you didn't like it? Yeah, Grant.
You multiply something by itself an even number of times, you're going to negate any and all negative numbers.
So what he's saying is if I have like -5 and you square it or raise it to the 4th or whatever, if you have -5 and you square it, you get +25, right? So when you take the square root of +25, you just get 5. That makes sense? So that -5 really turned into a 5. So if you have the square root of x squared, it's not just x. It's actually the absolute value of x. Okay? Or like if I had a positive already, if I had 7 squared, it's not like -x. It's 7 in the end, right? It's the positive version. So every time it's the positive version of the number. Does that kind of ring a bell? You remembering this? All right. So when we talk about the horizontal asymptote, we're taking this function that we had before, and we're approximating it. We're saying, okay, well, I know that I only have to worry about the biggest degree. Well, our biggest degree is not x squared. Do you guys see why it's not x squared? It's under square root, right? So it would be x to the 1st power. So on the top, I have a -1x. I'm ignoring everything else. I'm only worrying about the biggest exponents. And on the bottom, I have the square root of x squared, which makes the absolute value of x. So if you think about a big positive number and a big negative number going in for those, like even think about 100. If you plug in 100, you would have -100 on the top, +100 on the bottom. -100 divided by +100 is -1. Does that make sense? So if I plug in a big positive number, I get -1. But what happens when I plug in a big negative number?
Yeah, 1.
Why do I get 1 instead of -1?
Because -1 times, say, -100 gets you 100 over the absolute value.
Because the numerator is now
-100
positive. Do you guys see it? So that gives me +1. So those are the vertical or the horizontal asymptotes. So you get y equals -1 and y equals 1.
Do all functions have asymptotes?
No, sometimes we don't. Like, you know, y equals x squared. Does that have asymptotes? No, it just goes up forever on the right and left, right? Its limit would be infinity on those. And we'll talk more about asymptotes when we talk about limits. All right, so the next one. I have x to the 4th plus 5 all over x cubed minus 1. Now, x cubed minus 1 actually does factor. Do you guys remember how to factor that? It's the soap thing. So you think about it as x is being cubed minus 1 is being cubed. You drop the cubes, so x minus 1. Square each item, x squared. Square the 1, 1. In the middle, you multiply the two together. X times 1 is 1x. And then your signs are same, opposite, always positive. Do you remember that? Do you want me to give you another example of that?
Wait, don't you square the 1 too, or just the x?
You do.
X squared.
1 squared is 1, right?
X minus 1, x squared, what is that last one?
X squared plus 1x plus 1. Oh, did it run off the page?
Yeah.
Yeah, sorry. Mr. Clark was messing with my Zoom. All right, there we go.
Oh, that's one thing.
All right, so another example, if I had like 8x cubed plus 125, I identify it as being 2x is being cubed and 5 is being cubed. So if I was going to factor that, I would drop the cubes. I'd have 2x plus 5. I'd square the first item, 4x squared. I'd square the last item, 25. I'd multiply the two things together and get 10x. So same, opposite, always positive, like that. That's how that would factor. Is that all coming back to you? You're like, I don't remember this at all. It's been a long time. All right, anyway, so that's how that does factor. Now, if you tried to factor the part that's left, yeah, it doesn't actually factor. It's actually two imaginary answers. So our only vertical asymptote is x equals 1. So it wasn't totally necessary that you factored that. Could you guys have gotten the one vertical asymptote from the beginning, x cubed minus 1, if you set it equal to 0? Yeah, you get it. All right, horizontal asymptote. Yeah, what do you think?
Gotten a little confused over the vertical, actually.
Uh-huh.
How did you get x equals 1 from all that?
Because I set each piece equal to 0. So set this equal to 0, set this equal to 0.
Oh, right.
Does that make sense? Yeah. And then the second one has imaginary solutions. Yeah. That's correct. There's no horizontal asymptote because we have our largest degree is x to the fourth. So I have 1x to the fourth over 0x to the fourth. So when you have 1 over 0, it's undefined, right? So that means there's no vertical asymptote then. Or no horizontal, sorry. All right, feeling good about those? So the square root one is really the only thing that's new. All right, so let's do the domain of the functions. So domain is very similar to vertical asymptotes. Now, I will caution you with vertical asymptotes, always look to see if the numerator had the same factor. So if one of those last examples had the same factor on top and bottom, like x plus 2 and x plus 2 on the top and bottom, is that a vertical asymptote then? No, it's actually just a hole, right? So look for things like that. It wouldn't be in the domain then because it would be a hole. It's like a place where you don't have a point. So anyway, so on this one, if I'm finding the domain, I'm going to factor. This is a tricky one to factor. I like to put the 2x squared, 5x, and 3, and then I change around their signs because it's a hard thing to factor. So what a lot of people do is they think, oh, I'm going to put the 3 here and the 1 here, and I know my outer and inner has to combine to be -5, so I'm going to do negative and negative. Oh, that's the one that I wanted. Dang it. I thought I had a -3, and that works, right? But maybe they started out and they're like, oh, well, what if I have the 3 here and a 1 here and I want a -5? That's going to be negative, and that will be positive. Doesn't that kind of work? It works on the first and the middle term. Do you guys see it? Does it work on the last term, though? No, because we get a -3 instead of a +3. So that's why I like that one to put on test, because it's a tricky factoring problem. I try to trick you. All right, so anyway, so we have this. We know it's going to be the same sign, so they're both going to be minus. So we do have a 3 and a 1 like that. So there are two things that we are not allowed to have in our domain, two numbers. Okay, so if I set the 2x minus 3 equal to 0 and the x minus 1 equal to 0, I get x equals 3 over 2, and I get x equals 1. So for our domain, we would write all real numbers except for x equals 3 over 2. And x equals 1. Okay, kind of a lot to write, right? You know the easiest way to write it? X does not equal 3 over 2. X does not equal to 1. Isn't that easier? Put you through the torture of writing it all out. All right, if I don't put that it's a real number, you assume that they're real numbers. All right, so the next one, the domain, what can I not have? X is not allowed to be two numbers. Can you do it in your head? Positive and negative 5, exactly. Do we all see that? All right, the next one is a logarithmic equation. Log. What am I not allowed to take the log of? What do you think, Emily? She's like, no, not logs.
Square root.
You can have a square root. You can have like log of square root of 2.
It can be negative, it can be 0.
Can you? Let's try.
0 is the
Do
one.
log of a negative. So log of like negative 10 or log of negative 5. Try that on your calculator. Now some of your calculators are giving you something. So mine says error because I have mine set so that it's not like they're all real answers. If you have your calculator set in A plus BI form, so if you're a big cheater in one of your classes and you used to do 3 minus 4i times 5 plus 2i over 6 minus 2i on your calculator, maybe you have it set as A plus BI form. Did you know you could do that? Yeah.
I just recently.
So yours might give you something, but it's an imaginary answer. It doesn't work. Okay, so we cannot take the log of a negative number or 0. Okay, so that means that this part, the argument, that's what we call it, the argument, has to be positive, and it can't be 0. So must be positive.
Well, 0 is not positive.
Exactly. So I'm going to say 2 minus x has to be greater than 0. So that means 2 is greater than x. In other words, x is less than 2. So you can leave your answer like that. I'm fine with that notation. Or you can write it in interval notation by saying negative infinity to 2. All right, and then the last one has combinations of those things. So we have a square root, we have a logarithm. So the square root, we know that inside of the square root has to be greater than or equal to 0. So it could be 0 there. Square root of 0 is 0. Yep.
Hold on, I have a question.
Mm-hmm.
Can't you take the log of 0?
You cannot.
No, you can't. Never mind.
I know, the reason is because the log function is graphed like this. There's a vertical asymptote at 0.
Alright. I was gonna say, why can't it
Yeah.
equal 0?
Yeah, because really, like, if you have log, you're getting me on a tangent. Math pun. All right, let's see. So if I have log of 0 equals something, what you're saying is 10 to that something equals 0 when you write it in exponential form.
Which cannot happen.
Yeah, and you can't have 10 raised to any power equals 0. You could get close to it by raising it to the negative 10 trillion, but it's not going to actually
The
equal
only
0.
number that can be 0 in exponents when you're doing 0 itself, right? No other numbers can.
Right.
Yeah.
Like you could have like 0 to 2, but 0 to 0 is actually undefined.
Cool.
It's not 0. It's not 1. We don't know what it is.
That's weird.
All right, anyway, so I have a log base 3 of x. So I'm going to say x has to be greater than 0. Okay, we need for both of these things to be true. So we're finding as if they're on a number line where they're overlapping. Okay, so I'm going to solve. So I have x is greater than or equal to 1/2, and I have x is greater than 0. So if I think about where they're overlapping, I have the greater than 0, and I have the greater than or equal to 1/2. So what is my final answer?
1/2 to infinity.
1/2 to infinity. Everything that's greater than or equal to 1/2.
Just put x is greater than or equal to 1/2.
Yep. So let's think about it. If I plugged in 1/4, does that make it undefined? Yeah, because of the numerator. Does that make sense? So you would need both of those things to be true. All right, let's do some trig equations. Yes.
For B, why 25 minus x squared don't have to be like bigger than
Oh, you know what? Cyro just caught me. I was too speedy in that, wasn't I? Okay, so on number 2b, actually, she is correct. She gets a bonus point. Because we have 25 minus x squared, and we actually have to think about the number line there. So yes, we cannot have negative 5 and 5. I was forgetting that it's under a square root.
Oh,
So let's think about it. If I plug in 6, what happens when I plug in 6? 25 minus 6 squared. 25 minus 36. Is that good?
Negative 6 over square
That's
root.
bad. It doesn't work, right? What if I plug in negative 6? Doesn't work, right? Yeah, so it's in between here, and it cannot include the 5 and the negative 5. So the answer should actually be, instead of this, it should be parentheses negative 5 to 5, like that. Thank you, Cyro. I'm still on summer mind as well. All right, next up. So solving trig equations. So how many of you guys remember the unit circle?
Yes.
Should I have a unit circle quiz?
No.
Yes.
I was thinking about it someday.
I mean, actually, no, do it. Do it tonight. Yeah, please. Give me a easy.
All right, here we go. So solve the following trig equations. Give all answers on the domain 0 to 2 pi. So the first thing we have is sine of x equals negative root 2 over 2. All right, so if I have sine is equal to negative root 2 over 2, I draw my little unit circle. And what I'm saying is that sine is the y value on the unit circle, and it's negative. So it could be in quadrant 3 or 4. So those are going to be here and here, directly in the middle. Do you remember what those values are?
5 pi over 4.
Ethan. Ethan. Yes, x equals 5 pi over 4 and 7 pi over 4. Correct. Good job. He's fresh out of summer pre-calc. It's on his mind. He likes unit circle. You have to, don't you? Is the unit circle your best friend? Yes, it might be my best friend. I don't have very many friends now. That would be very sad. All right, anyway. So this next one is a little bit tricky. If you have cosine squared x equals cosine of x, you have to be very careful. You do not have to square the other side. Think about it like this. Let's say I had this. If I divide by w, I actually lose one of the solutions. That would just give me w equals 1. That is not the correct answer. We are not allowed to divide by w or cosine of x on both sides. What you would technically have to do if you had like w squared equals w is you would have to subtract the w over so you could pull out the GCF because you have two solutions. You have 0 and positive 1.
That's what I have to do.
Okay, so that is what we're going to do on this example. We are going to subtract the cosine of x over. So we're going to have cosine squared x minus cosine of x equals 0. So I'm going to have cosine of x. So cosine of x times cosine of x minus 1 equals 0. And I set each piece equal to 0. So if I'm talking about where cosine is equal to 0, that's the x value on the unit circle. Well, this point is 0, 1, and this point is 0, negative 1. So they have x values equal to 0. So that happens at x equals pi over 2 and 3 pi over 2. And then the last one, cosine of x equals 1, I hear someone whispering it. 2 pi and 0. Now I'm just writing 0. Why am I just writing 0? Look at your original. It says find all solutions on the domain 0 to 2 pi. Yeah, Ethan? Since it's a parenthesis, you don't actually need to include the solution of 2 pi. Okay, that's too much information. Do you get it? Because it's not on the domain. All right, so those are our answers then. So pi over 2, 3 pi over 2, and also 0. All right, so same idea on the next one. So we're going to pull the sine of x to the other side, and we're going to factor it to the front. So I'm subtracting it over. I'm pulling the sine of x to the front. I'm left with 2 cosine of x minus 1 equals 0. Yep, so I have sine of x equals 0. And I have 2 cosine of x minus 1 equals 0. So if I solve that, I get cosine of x equals 1/2. So sine is equal to 0 in 2 locations. What are my answers there?
0 and pi.
0 and pi. And then on the other one, cosine of x equals 1/2, that's 2 locations. What are they?
2 pi over 3 and 4
Grant?
Pi over 4 and 7 pi over 4.
Close, but they're not in the middle. Yeah, Ethan?
Pi over 3 and 5 pi over 3.
Yep, pi over 3 and 5 pi over 3, exactly. So I get 4 answers. So I have 0, pi over 3, it's like the 60-degree one, and 5 pi over 3. Notice I'm not doing anything in degrees. We don't do degrees in calc, we only do radians.
It's the cosine of x equals 1/2.
Cosine equals 1/2, yeah? That's right.
When the cosine is 1/2.
That's right. Cosine is 1/2, that means you go over just a tiny little bit. All right, so cosine squared equals sine squared. So let's think through this one. So what if I just had cosine of x equals sine of x? There are 2 answers on our unit circle. What that's saying is where is the x value equal to the y value on the unit circle? There would be 2 locations. Will, do you know?
Yeah, pi over 4 and 5 pi over 3.
Exactly, because we'd have root 2 over 2 comma root 2 over 2, and negative root 2 over 2, negative root 2 over 2, okay? So this is a little tricky because this is cosine squared equals sine squared. So we're not just going to have pi over 4 and 5 pi over 4. We're actually going to have 4 answers. All right, so if I take the square root of both sides, square root, I don't get cosine equals sine. I actually get cosine of x and sine of x, but they both have plus or minus. Now putting plus or minus twice is kind of redundant. We don't actually need it. Yeah, is that what you're going to say, Grant? Okay, good. The reason it's redundant is because imagine we had plus or minus x equals plus or minus 2. The 4 answers would be positive x equals positive 2, negative x equals 2, negative x equals negative 2, and positive x equals negative 2. Do you see how two of those answers are identical? Like these are the same and these are the same. So we don't need a plus or minus on both sides. So anyway, Grant thinks he has the answers. Grant, what do we think they are?
I think that they're all of the ones where pi is over 4.
It is. So we have pi over 4, 3 pi over 4,
Just said that.
5 pi over 4, and 7 pi over 4. Those are our 4 answers. You getting this? Some of you are giving me the, oh, I've totally forgotten this, and some of you are like, yeah, unit circle. So we'll see. All right, so this next one I think was pretty easy. You would just add the root 3 over and divide by 2. So you'd have cosine of x equals root 3 over 2. Can anybody do that in their head?
The root 3 over 2 or the answers?
The answers.
Pi over 6 over pi over 6.
Yes. Did you really do it in your head or did you write it down?
Well, I wrote it down first by date in my head before I didn't draw a circle, I did it in my head and then I wrote it down because I wrote the answer.
All right, so this, yeah, so basically it was because cosine of x was equal to root 3 over 2. So it was in 2 locations. It was here and here and here. All right, so 4 sine squared x equals 1. So if I divide by 4 on both sides, I get sine squared equals 1/4. So if I take the square root, plus or minus, I get sine of x equals, what's the square root of 1/4?
Plus or minus 1/2.
Plus or minus 1/2. So how many answers do I have? 4.
4.
Yep. I don't know why I'm like a little bit off. It's hard to draw my these parts. All right, here we go. All right, so my answers are going to be x equals pi over 6, 5 pi over 6. What's the next one? 7 pi over 6 and 11 pi over 6. Good. You guys are making me so happy. You guys remember your unit circle. All right, I always say, like, you never know. Like, you always know how AP Calc is going to go if the first day I'm like, what's secant? And then people are like, 1 over cosine. And you're like, okay, this is going to go well. And then, what's secant? And then you're like, oh, man, they don't know the pre-calc. All right, so you guys know your unit circle even. That's good. All right, so factoring. So something like this. If I subtract the 1 over, all right, this is one that is kind of like a W substitution. So if we thought about it with a W, I would have 2W squared plus W minus 1 equals 0. And I would know how to factor that. I would know that it would be 2W and W. I need my 1 and my 1. And my outer and inner need to combine to be positive 1. So I would need a positive on the far right and a negative first. Okay? So that's how this is going to factor, only I'm going to keep the sign in there. So I'm going to say 2 sine of x times a sine of x. And I know I need a 1 and a 1. And I need the negative first and the positive second. Do you guys see how that works? All right, so when I set each piece equal to 0, the first one's going to give me sine of x equals 1/2. And the second part's going to give me sine of x equals negative 1. So sine is equal to 1/2 in 2 places, right? That's going to be pi over 6 and 5 pi over 6. And sine of x equals negative 1 down at the bottom of the unit circle. So that is going to be 3 pi over 2. Okay, does that make sense? Now the next one is set up the same way. You would factor. So when you factor, you're going to have 2 cosine of x 1 and 1. Oh, it actually doesn't factor, does it? I must have a mistake on that. I meant for it to factor. It does not. I don't know what I wanted it. Maybe I wanted a 3. Is this a 3? Let's make that a 3.
Should it be cosine of x or sine of x?
Oh, it is a sine of x. Oh, that's what my deal is. So I do. Okay, that's right. So I tricked myself with my notes, didn't I? You'd have to make them all into like sines or cosines. So what I would do is I would replace this cosine squared with 1 minus sine squared. Do you remember how to do that? Okay, and then you would factor. What if you get something weird in the end? What if you get like sine of x equals negative 3? Can that happen? Can sine of x equal negative 3? What's the biggest sign can be and the smallest sign can be? Think about the unit circle, yeah.
1 and negative.
Yep, sine is always between negative 1 and 1. So if you had that, that would be not possible. So no solution on that one. Does that make sense? So if you ever factor and you get one of them is weird, like sine of x equals 4, right? That's just not adding a solution to your answer, okay? So I did not do the double and the triple. Those are the ones where you actually, like, instead of going on 0 to 2 pi, you do a w substitution and you go on 0 to 6 pi and find all the answers. And then divide by 3. We'll do that next time. And then the 2x one, you go from 0 to 4 pi. Do you guys remember how you double the interval? So I'm going to give you your homework, and I want you to start it. Do as much as possible. Because, yeah, we're going to do the next section next time. So see what you can do and what you can't do.